A century later, all of nature had been classified into two great domains. There was energy, the forces that animated objects, and there was mass, the physical stuff that made up those objects. The whole of 19th century science rested on these two mighty pillars. The laws that governed one did not apply to the other. But young, newly enrolled physics student Albert Einstein didn't like laws.
Good grief, Einstein. What happened to you?
It is more than a little ironic, having been reprimanded yesterday by that idiot Professor Pernay for poor attendance, that I should in fact attend a practical lesson, which was as long as it was boring and utterly pointless, by the way, only to be the victim of an explosion of my own apparatus.
So it was your own fault then?
Thank you. And how are you today, Fraulein Marriage?
Extremely well, Herr Einstein. All the better for seeing you have escaped the physics laboratory with your life.
Well, in order not to alarm you any further, I pledge to forever continue my studies here at the Café Bahnhof, reading only the great masters of theoretical physics and eschewing the babbling nonsense of the polytechnicians.
It's about all you ever do.
It's getting a little stuffy in here, Fraulein Marriage. Would you care to take a walk with me? There's something I'd like to discuss with you.
Why, Herr Einstein? Of course. Perhaps you'd like me to tell you what you have missed in lectures this week.
Einstein wasn't exactly a model student. He excelled in certain subjects, especially physics and math, but he wasn't very diligent in a lot of his other classes. He was undoubtedly very questioning, which seems to have annoyed most of his professors throughout his life. He would pursue his fascinations with just incredible determination.
We know from his letters that Einstein, even from the age of 16, was literally obsessed with the nature of light. Everyone he could speak to, his friends, his colleagues, even his then girlfriend, Mileva Merrick, who would become his wife, everyone he badgered with the question, what is light?
What would I see if I rode on a beam of light?
What? A beam of light? By what method do you propose to ride on this beam of light?
The method is not important. Let us just imagine we two are young, radical, bohemian experimenters, hand in hand on a journey to the outer reaches of the universe, and we are riding on the front of a wave of light.
I really don't know what you are suggesting, Herr Einstein. Do you wish to hold my hand or ridicule me?
Ridicule you? No, never. I merely want you to help me to understand. What would we see, you think, if we were together and we sped up and up until we caught up to the front of a beam of light?
It was Einstein's relentless pursuit of light which would bring about a revolution in science. With light, he would reinvent the universe and find a hidden pathway that would unite energy and mass. Light moves incredibly fast, 670 million miles per hour. That's why scientists use the term C. It stands for celeritas, Latin for swiftness. Long before the 19th century, scientists had computed the speed of light, but no one knew what light actually was. Back in England, a man we've already met was willing to make an educated guess. After Sir Humphrey Davy's death, Michael Faraday became Professor Faraday, one of the most important experimenters in the world. The scientific establishment still found it hard to accept that electricity and magnetism were just two aspects of the same phenomenon, which Faraday called electromagnetism. But now, he has an even more outrageous proposal for his audience.
Invisible lines that can emanate from electricity in a wire, from a magnet, or even from the sun. For it is my contention that light itself is just one form of these vibrating lines of electromagnetism.
For 15 years, Faraday struggled to convince the skeptics that light was an electromagnetic wave, but he lacked the advanced mathematics to back up his idea. Eventually, someone came to his rescue. Professor James Clerk Maxwell believed in Faraday's far-sighted vision, and he had the mathematical skill to prove it. Maxwell and the aging Faraday became close friends.
James, forgive me. A word of advice. Don't get old.
Michael, how are you?
I'm fine. Memory isn't too good. But...
Well, I thought you might like to see what I've just published.
Oh, yes. Yes. Splendid.
So your results show that when electricity flows along a wire, what it actually does is create a little bit of magnetism. And as that magnetic charge moves, it creates a little piece of electricity.
Electricity.
Electricity and magnetism are interwoven, like a never-ending braid. So it is always pulsing forward.
It's wonderful.
Michael, there's something very crucial in the maths. This electricity producing magnetism and magnetism producing electricity, it can only ever happen at a very particular speed. The equations are very clear about it. They come up with just one number. 670 million miles per hour.
I'm not sure.
It's the speed of light. That is the speed of light. That means you were right all along. Light is an electromagnetic wave.
Maxwell had proven Faraday right. Electricity and magnetism are just two aspects of a deeper unity. A force now called electromagnetism, which travels at 670 million miles per hour. In its visible form, it is nothing other than light itself. And nothing fascinated the young Einstein more than light.